Hello, welcome back. I hope everyone had a great week. Um, Today we're going to continue with our function package, so let's get to it. Now, 31. The function below can be used to find PNX, the monthly profit in thousands of dollars of a manufacturing company based on X units sold. So PNX equals, you see there the function. What is the value of PN5? So basically, every time you see a variable here, it just means that in this case, x, you see, here is p in x, here is p in 5. So therefore, x will be equal to 5. P in x the variable inside of the parentheses, then you see 5 inside of the parentheses, so x equals 5. So what we are going to do is just substitute the value of x inside of the equation. So I have p in 5, and this is going to equal negative 0.4 times 5 plus 100 plus 80 times 5 minus 60. So this will be negative 0.4, 5 plus 100, 105. Now, 80 times 5 is 400 and minus 60. Now, 0.4 times 105, so 0.4 times 105. That's 42, but since we have negative and this is positive, it will be negative 42. And then 400 minus 60 is 340, so plus 340. And then 340 minus 42 is just 288. And this is our answer. And here we have it. Now, the total monthly cost of a cell phone bill is given by, okay, we have another function there, where D is the number of devices on the plan. What is the total monthly cost of a plan with 3 devices? Or if D is the number of devices, then 3 will be D, because we have 3 devices. 3 is the number of devices. So in this case, D will be equal 3. Now, so it will be F in 3, because this equal 3. So this we have 50, and then it will be 25, and here's this, so 25 times 3 will be 50, 25 times 3 is 75, so plus 75, and this will be 120. So this is the answer. Now let's see 33. The function g in x equal to 1000 times 1.2 to the x represents the population of a rapidly growing city X years after the year 2010. Which of the following statements are true? So let all that apply. So let's see. We want to know G in 0. So let's see here, G in 0. And this will be 20,000 times 1.2 to 0. Like every number to the 0 is just equal 1. So this will be 20,000 times 1, which is just 20,000. So this is true. Now let's see if what is after that is true as well. So let's see. Represents that the population in 2010 was 20,000. So yes, you can see here X means amount of years after 2010. So if x equal 1, there will be 2010 plus 1, which is 2011. And so yeah, 0 will be the population in 2010. So yep, this is true. Now let's see. In 10. Let's calculate it. I'm just gonna go to my calculator. We cannot do that. Well, no, we cannot do that by hand. So we have 20,000 times 1.2 to the 10, which is approximately 123,835, because it's 0.7, so we take one more. And also every time we're talking about persons of or cars or something like that, we always take like one more. So this will be 100 oops 123 1,834. So this is 35, sorry. So this is true. Now let's see if the other part is true. Represents that the population in 2020 was 100, like that number. Um, Again, that's true because we're taking X years after 2010. So if it is 10 years after 2010, there will be 2010 plus 10, which is 2020. So this is true as well. Now let's see. This is false. This is not true because we just calculated the population is not 240,000. Now, gene 10 minus gene 9 represent the population in 2019. Right now, I can say this is false because we have already established that for the population in another year, the population in 2020 is gene 10. So the population in 2019 will be gene 9. This itself, this alone, is the population of 2019 because it's the population X years after 2010. 2019 minus 2010 is 9. So gene 9 will be the population at 2019. So this is fake because of that. And now let's see. Gene 10 minus gene 9 represents the population increase from 2019 to 2020. And that makes more sense because as we said before, 2020 is the population like 20 wait gene 10 is the population at 2020 and gene 9 is the population at 2019, so it will be population 2020 minus population 2019, so therefore it will be the increasing, like the increasement from 2019 to 2020. So yep, this one is true. Now let's see theory 4. I'm sorry, a pond has 150 fish, and the population decreases by 8% each day. Okay, they actually give you the equation, so it's not that bad. So the situation can be represented with the exponential decay function. Okay, now they give you the function, so that's not that bad. And they just say find f in 4. So we just substitute the x, so it will be 150 times 0.92 to the 4. So we got total calculator. 50 times 0.92 to the 4. And it is approximately 108. So this is approximately 108. Well, if they have here 107, so close enough. Yeah, like if you round it, it will be 107, but there are some rules in mathematics that when you're talking about like actual things that you cannot put in decimals, you always take one off. But yeah, it's fine. So approximately 110 and 7. That's the beauty of multiple choice. So you can see the one that actually is. But now, what does F in 4 represents in terms of the given context? So let me see. A pound of 150 fish, blah blah blah. The population decreasing, The situation can be represented with the exponential decay function. Okay, now, this is the initial population. This is how it is decreasing. Therefore, all this needs to be like this, give you the population at a specific moment, like 3 years later or 4 years later, we just calculated. So F4 represents the population for days later. Because it's saying 8% each day. We're putting 4, so it will be 4 days after that. Let me see. the fish population in the pond after 4 days. That's just what I said. Let me just read the others, but I like this one. The fish population in the pond is decreasing for 4 fish per day. No, that has nothing to do with it. Actually, they say it is decreasing 80% each day. So, no. The difference between the initial fish population and the fish population on the day. Again, that's nothing. I'm sorry. That's nothing to do what we are doing. The difference between the initial fish population and the fish population after 4 days. Again, we are not looking at a difference of anything. So yeah, it is 8. So let's see the function. Models estimated home value after 3 years. After 5 years, the estimated home value is, so okay. So we have 5, so this will be being 5. And it will be 210,000 times 1.2, 1.02 to 5. So, oops, 210,000 times 1.02 to the 5. This is approximately 231,857. So 231,857. So that's the value here. After 10 years, the estimated home value is, so we just do being 10, which is 210,000, 1.02 to 10. We just put it here, and it is 255,989. Easy. It is 8 again. Now, there 6. Use the graph below to answer the question. What is the average rate of change of the function from x1 to x2? This is used the slope. When they say the average rate of change, it just means the slope. So we take the point at x1, which is 60, so it will be 1,60. And then at x2, which is 1,20, or 2,20, I'm sorry. And we find the slope, so it will be 20 minus 60 over 2 minus 1, which is negative 40 over 1, so negative 40. This is the average rate of change. Now let's see here, to 7, the graph of a function is shown. What is the average rate of change between 0 and 2? So the same. I'm going to get 0. So x0 is here, so it will be 0,4. And then here it will be 2,0. And the slope will be 0 minus 4 over 2 minus 0, which is minus 4 over 2, which is minus 2. Which is C in this case. Now let's see. This is another function, so it's graphed on the coordinate plane below. Okay. If the following statements are true, so it all will apply. Let's see. In the interval 4.4 to 10, the average rate of change is 0. So let's see, 4, 10. Yeah, like this. Actually, you can see it. But if not, you can just try to calculate the slope. It will be 10 minus 10, which is 0 over 10 minus 4. And 0 over any number is just 0. So yeah, also you're seeing that it is a horizontal line. A horizontal line has no slope. And the rate of change is slow. So yep. Now in the interval 10 to 16, sorry, the average rate of change is 1. So let's see. We have 10, we have 16. So it will be, oops, this 16. 16, comma 16. and this will be 10,10. Like straightforward. I can say that it looks like 1, but either way, we say 16 minus 10, or 16 minus 10, which is 6 over 6, 1. So yeah, B is true as well. Now, the average rate of change between 2 and 4 is decreasing. So it's going down. Let's see. 2 and 4. So 2 comma 2 and 4 comma 10. So let's see if it is negative. And if it is negative, it is decreasing. So 10 minus 2 over 4 minus 2. So this is 5 over 2. Oh, wait. 8 over 2. I'm sorry about that. Which is 4. And it is positive. It is positive 4. So this is not true. It is increasing, not decreasing. Now, if it be equal to the 4, we just calculated. Wait. The average rate of change is greater than the error rate of change in the interval 10 to 16. So we know that in 10 to 16 it was 1. And in this case, we can calculate it. So we have n times 2 over 4 minus 2. So this is 8 minus 8 over 2, which is 4. I think I calculated before. I just don't remember. Oh, yeah. Right here, we did the thing twice. Either way, from 10 to, like, from 2 to 4 is, yeah, indeed greater. Now, E in the interval 10 to 16, the average rate of change is greater than the average rate of change of 2 to 4. And no, that's not true. We calculated it was smaller than that one. Since this one 4, this one is no. Let's continue. I'm sorry, by mistake I pressed the stop button for to continue. Now the graph shows very nice. The graph shows the transportation budget for the local school district, the project budget from 2023 to 2028. What is the average rate of change from the project budget from 2010 to 23? Okay, and your answer to the nearest dollar. So we're looking to 2010 to 23. So in 23, 13 years after 2010, so here is the point mark here. And then 2010 is year 0 because we're starting from 2010. And we have the point label. Now, our rate of change is just slow. So we're looking at this red line. And we have the point, so it will be 180 minus 117 over 13 minus 0. Oh, minus 0. So this will be 63 over 13. We can calculate it. So 63 over 13, approximately 4.85. So this is about 4.85. Do they say run your answer to the nearest dollar? So we are just going to say $5. Just put the 5, don't put the dollar sign. Now let's do 40. The table below shows data from a recent car trip for the Burke family. Okay, that's all the data. State the average rate of change for the distance traveled between 2 and 4. Okay, we have 2 here. We have 4 here. Run your answer to the nearest 10 and include appropriate units. So let's first, do this. Hours after leaving the family, mile from home. So we're going to average rate of change is just slow. So we're going to say 238 0.53 miles minus 112.12 miles over 4 hours minus 2 hours. So we can use a calculator for this. We have 238.53 minus 112.12, and then 4 minus 2 is just 2, so we divide it by 2. So this is 63 points 63, and we say put to the nearest 10, so it's 1 after, you know, this is 10, this is 10, 800. So 10 is just 1 after, so it will be 63.2 miles per hour, or miles over hour, however you want to write it. Plus miles at the top, hour at the bottom. So this is 63.2 miles per hour. And remember, we're including the units because they said include appropriate units. So be careful with that. No, 41. The graph on the coordinate plane below models the height of the ball after it's thrown up in the air from a platform. The equation is, we have the equation there. Approximate the height of the ball in feet after 80 seconds. Which statements are true? Select all that are. So for A, the average rate of change between 0 and 2 is 32 feet per second. So let's see that. We have 0 here, we have 2 here, we have the point. So let's see the slope, 144 minus 75 over 2 minus 0. So this is 69 over 2. We can make sure about that. So 144 minus 75. Yep, and over 2, this is 34.5. So this equals 34.5. And what did this say? This is 32, so nope, that's not the answer. Wait, maybe, yeah, this over 35. I think it's 80. It never, oh, yep, it's 80. And you know how I know it? Remember that this is the y-intercept because it doesn't have a variable. So let me change the value here. This is 80. This is going to become 64. And then this will be 32. And always be careful because from far away it looks like 70. But this is the line. It's actually a little bit over that. So that's an 80 and this is the 2. So A true. Now let's see B. Now between 2 and 3 also 32. Let's see that. First of all, isn't weird because I entered to positive and it's going down. But let's see. Either way, what is the answer? 2021 3. And this is approximately 3,103. I will say that it's close enough. So let's see, it will be 130 minus 144 over 3 minus 2. So this is equal negative 14 over 1. So it's just negative. And it's not even here. So it's super simple. Now, the average rate of change in feet per second between 0 and 1 seconds is the same as the average rate of change between 0 and 3. So let's see. From 0 and 1, we have this is going to say 1,130. So, 130 minus 80 over 1 minus 0. So this is just 50. And then this is 3,130. So it's the same, 130 minus 80 over 3 minus 0. So this is 50. over 3. So it is not the same because we need to take into account the amount of time that is happening. So it's not the same. Now the average rate of change in feet per second between 0 seconds and 1 second is greater than the average rate of change between 1 and 2. So the average rate of change between 1 and 2 is 144 minus 130 over 2 minus 1. So this will be 14 over 1 or just 14. And then the rate of change between 0 and 150. So between 0 and 1 is greater than between 1 and 2 because 50 is greater than 14. So, yep, it is greater. So this is true. Now let's see. If the average rate of change in feet per second between 0 and 4 is the same of the average rate of change between 1 and 3. So let's see that. So, sorry about that. We have 0 and 4. We have 80 minus 80 over 4 minus 0, which 80 minus 80 is just 0, so our answer is 0. And now the other one is 1 and 3. So in 1 and 3, we have 130 minus 130 over 3 minus 1. And this is just 130 minus 130 is 0. So our answer is going to be 0. So yeah, it is the same. They are both 0. Now let's see the next question. No, 42. Look at the data represented in the graph. Which of the following statements are true? So it all apply. From 2017 to 2018, the recycling rate in series A decreased. So from 17 to 18, yes, it decreased. Why? Because it went down. When it is going down, it is decreasing. When it's going up, it is increasing. So it's going down, so it is decreasing. Yes, it is true. Now from 17 to 19, the average rate of change was 0. So in 17 here, we have 19 here, and we make a line. We can either um calculator or just see it. You see this is a straight line to the right. When we calculate this, it will be 30 minus 30 for 2019 minus 2017. But the value in the bottom doesn't matter because 30 minus 30 is just 0. So yeah, it's 0. And it's true. Let's see, C from 17 to 22, the average rate of change is 4% per year. So it's 17 to 22. So this is 17. This is 22. This is what we want to see, to know. So 20, oops, it will be 50% minus 30% over 22 minus 17 is going to be equal 20% over 5, and this equal 4%. Yep, this is true as well. And now from 2018 to 2022, the average rate of change is 30% per year. This seems suspicious. I don't think so, but let's see that. So let me delete this. No, so let me see. This is 2018. This is 2022. So we want to know this. Oops. So we have, it will be 50 minus 20 over 22, 2022 minus 2018. So 50 minus 1 is 30, 22 minus 18, 4. So this will be 30 minus 8 over 4, which is 7.5. And look, it's not 30. So yeah, this one is fake. Now the average rate of change from 19 to 20 is greater than from 18 to 19. So let me see that. We have 19 here, we have 20 here, we have 18, we have 19. So we can see this one is going up faster than this one. So I know this one is greater, but you can calculate it. So we have 50 minus 30 over 20 minus 19 is just a year. So it will be 20%. And then in this case, we have 30 minus 20, which is going to be 10%. So yeah, this one is a lot greater. So this is true. Now let's see, next one. A quadratic function is given below. What is the average rate of change from the interval 1 to 5? Now, this is a tricky one because they do not give us the exact point. We need to find it out. We have the value for x. So, what we need to do is find f in 1 and f in 5. So, that's the interval we are working for. So, we have f1 equal -2 1 squared plus 4 1 plus 3. Now it will be -2 times like 1 squared is 1, so -2 times 1 is -2, 4 times 1 is 4, 3 is just keep being 3. So this will be 4 minus 2, 2 plus 3, 5. So our first point is 1, comma 5. Now we need to see what is f in 5 because they say on 1 to 5 here. So it will be -2 5 squared plus 4 times 5 plus 3. This will be -2. 5 squared is 25. Then 4 times 5 is 20. We will just keep the 3. Now, -2 times 25 is -50. And then 20 plus 3 is 23. So -50 plus 23. Now we keep the sign of the greater one. The greater one is 50, so we keep it negative. And we say 50 minus 23, which is 27. So it is -27, and our second point will be 5, comma -27. And now that we have our 2 points, we can calculate the slope, which is going to give us the rate of change. Now we have -27 minus 5 equal, like over 5 minus 1. So they have the same sign, so we skip the sign and add them together. 25, 27 plus 5 is 32, so negative 22, 32. And then 5 minus 1 is 4. And now 32 divided by 4 is 8, so it will be -8. And here we have the answer. Negative because we keep the sign of 32. Now let's see 44. Mary typed the first draft. I think this is going to be the last one. Yeah. Mary typed the first draft of a term paper over a period of 3 hours. She kept track of the total number of words she typed over the entire period. The data are graphed below. If the function graph is WT, then what is the value of W60 and what does it mean? So I'm going to go here. I know this is W, which is the time. Wait. This here is the X, T time. So I come here, this is the time, and I say when the time is 60. So what I'm gonna do is come here, I know the time is 60, make a line up, and I say this is the point. And when I connect it to the left part, I say that this is 2,400 words. So at when she was at 60 minutes, she has typed 2,400 words. So Okay, W60 equals 2400. True. This is not true. This is not true. It's just 2400. Now, this means that Mary typed 60 words during the first 2400 minutes. No, it doesn't make sense. It's 2400 words in the first 60 minutes. That's what happened here. So this just doesn't make sense. And then they say this means that Mary typed 2400 words in the first 60 minutes. Yeah, that's exactly what it is. And now this just didn't make sense because we are connected here. Now let's say B. Calculate the average rate of change of WT during the second hour from 60 to 120. Okay, let's first calculate the average rate of change. So we have 120 here. Now this is going to be an approximate, and I hate those. But I could say this is like 4,200 because this whole thing is 800 and it seems like half of the half. More or less, I would say this is 120, comma 4,200. And then this 60, 200, 2,400. Now we calculate the slope for that. And we say 1,100 minus 2,400 over 120 minus 60. So this is going to be equal 1,800 over 60. And this is 30. And we said that our answer was 30, so we take away this and we take away this. That's not what we are looking for. And we have either C or D. So the average rate of change is 30. It means that Mary type and on average 30 words per minute during the second hour. Well, that's exactly what we're talking about, no? We use the minutes, so this is like, we can take 400 to W because of words, and then M because of minutes. So it will be words, it will be minutes, so it will be 30 words per minute. You know what I mean? And then this one doesn't make sense because they say 30 hours, 30 words per hour, which actually in the real world, yes, doesn't make sense as well. So that's not the answer. Um, yeah, I think I can do this last one. Really quick. So let's see this. These last two. Yeah, I'm gonna do them really quick. So the profit earned in dollars by a computer manufacturing company when increasing the selling price per computer by X is by the function. Okay. Calculate the average rate of change of profit between a 20 increase and a 50 increase. What does this rate of change mean in terms of the profit made by the company? So with being 50 and being 20, we don't have those. So being 20, I'm just going to put in the calculator since I'm going a little bit fast. So it was a negative 5 times 20, you know, a square, 20 squared plus square plus 1,020 plus 500. Yeah, it will be, 5,000. Wow. This will be 23,000. Now being 50. Wait. Equal, the same, but instead of 20, we will 50. It will be 42,500. Now, if we want the other relation, we'll say 42,500 minus 23,000 over 50 minus 20 minus 20. This will be 18,500 if I'm not mistaken over 30. I just need to make sure about that. So we have this minus 23,000. Oh, it's 19. Okay, my bad. And then divided by 3, which is 650. This is the average rate of change, 650. We take out B and D because just 1 0. So here, let's trade these two for each dollar increase in the selling price of the computer between 20 and 50. Increase the company average 650 less profit, and this is the same, but with cases more profit. Now, as you can see, we actually got a positive result. So since we got a positive result, we are going up. It means that we're gaining. We are getting more of it. So this will be the answer, and this just wouldn't make sense because we got a positive result. So it is C. Now we do 46. What is the average rate of change of the function of an f in n of 1.3 to the n in the interval 2 and 3? Enter the answer in the box. So let's see. F in 2, 1.3 is just 1.3 to the 2. So 1.3 to the 2 is 1.69. And let's see F to the 3. F in 3 is 2.197. 2.197. Now the average rate of change is low, so 2.197 minus 1.69 over 3 minus 2. So this is minus 1.69. This is 0.507 over 1, which is the same as 0.507. Now it says nearest to the 100 to the nearest 100. Now nearest 100 is 2 place, so this is approximately 0.51. And this is our final answer. Always check to where they want you to round the answers. So yeah, that's all for today. I'll see you guys next week.